Hello everyone, this is Anil from International Dataspace Association, and today we will be having this session sponsored by FlexiRobots project, where we will be talking about unlocking interoperability and the Dataspace Protocol in deep detail. So we have a flow like this. So we will be starting by presenting the Dataspace Protocol and its specifications and features. Then we will be diving into the open source implementations of the Dataspace Protocol, uh, where we will be having presenters from Eclipse Dataspace Components and Fiverr Foundation, and then we will be jumping into the research projects tackling interoperability through the use of Dataspace Protocol. And in the last session, we will be talking about open source ecosystems for sustainable outcomes, where we will be having a presentation from Eclipse Foundation. So today we have a wide variety of speakers, and so we will be starting with Markus Spiekermann, who is the head of data business department of Fraunhofer ISST, who is also the project lead for the Eclipse Dataspace components. Then we will be continuing with Jesus Ruiz, who is the acting CTO of Fiverr Foundation. And then we will have Gonzalo Gil, who is a researcher in the Intelligent Information Systems unit in Technica. And he will be presenting the DigiCheck project today. And we will be having Jordi Arjona, who is the coordinator of the Distributed Systems Group and also in ITI, and also presenting Datamites project. And finally, we will be having Michael Plage from Eclipse Foundation, who is the vice president of the ecosystem development. And at the final stage, we will also have a presentation from my dear colleague Ignor Chulani and about what's coming next and what is our vision about this open source and the Dataspace Protocol. So I will be starting with the Dataspace Protocol specification first. So first of all, we have these two terms, intra-dataspace interoperability and inter-dataspace interoperability, which we are talking about a lot in the last years. So when you think about these two terms, one should always take into consideration that intra-dataspace interoperability is this interoperability of the components that make a dataspace, and inter-dataspace interoperability is about how a dataspace instance is able to communicate with the other dataspace instances. So as we know that a lot of people are in this projects about implementing dataspaces, so one thing to consider is that in all projects, inter-dataspace interoperability should be the default mindset to consider. So once you are implementing a dataspace, you should always consider that how it will be communicating seamlessly with other dataspace instances. For example, if you have an agriculture dataspace, then you should be considering its inter-dataspace interoperability, which means that how it will be communicating with another agriculture dataspace or with other dataspace instances from other industries. So this inter-dataspace interoperability is looking and sounding quite easy, but it's not. But here comes in the Dataspace Protocol. So this slide is basically showing how IDFA is tackling these challenges of interoperability according to the European Interoperability Framework. So we have these layers, these 4 layers of technical, semantic, organizational, and legal. But today's focus will be the Dataspace Protocol, which is the very important tool for ensuring technical interoperability. So currently, you can see the Dataspace Protocol on GitHub. So we have a repository for that, which is called IDS specification, which is under IDFA GitHub. And we also have the rendered version of the identical content, which is available as part of our knowledge base on our website. So the most radical change in the Dataspace Protocol is the separation of the control plane and the data plane. So this provides a lot of advantages. So to count some of them, so one can speak about flexibility, because basically you are separating the decision making from action taking. So decision making stands for the control plane, and action taking is about the data plane where the actual data transfer is happening. So it allows the data space to be able to use different data space protocols and without changing the control mechanisms, because a separation between these two planes has been already made. And you have a scalability advantage, so it's easier to scale each plane independently based on the needs of the system and the context. So if you saying that if you applied a very successful control plane and you don't want to change it, so you can just focus on the data plane and then adopt your implementation into another context quite in an easier way. And you have the security advantage, of course, because control plane focuses on the secure and trusted data exchange, and on the other hand, data plane focuses on the efficient data transfer, so that if you want to optimize something about the security or trust mechanisms, or efficient data transfer, or if you want to optimize your data transfer, so you can just focus on one plane rather than focusing on the entire implementation. And you finally have a modularity advantage. So because once you change something in the data transfer process, you can just do it without affecting the control mechanisms. And the same also applies for the other situation where you can change the control mechanisms without affecting the data transfer process. So basically, in its structure, it's consisting of three protocols, three layers. So the first one is called the catalog protocol. The second one is the contract negotiation protocol, and the third one is transfer process protocol. So basically, if you think about how this is happening, what these protocols are playing a role in the data exchange that happens between a data provider and a data consumer. So you can think about it like this. In the catalog protocol, the provider sets a clear list showing what kind of data they have for available, and consumers can view this to know what's available for them. And provider ensures that the data list is secure, and it's only shared with the authorized consumers. And then in the contract negotiation protocol, so the provider and the consumer go through several stages where the contract negotiations are happening. So specific messages are exchanged between the parties, and the consumer sends a proposal message, and provider might reply with an acceptance or rejection. So after passing this one, we come to the transfer process protocol, which starts once the contract between parties is agreed. And there in the transfer process protocol, the control plane acts like a manager overseeing the rules, and the data plane, on the other hand, is acting like a transporter of data between parties. And here, data is sent by the provider with a push, and requested by the consumer with a pull request. And there are a lot of differentiations and a lot of specifications about this in the existing version of the Dataspace protocol. So this slide is basically about the comparison of the internet and the data spaces. So basically, once you think about it, you can always say that there are some similarities and also some differences. But basically, both the internet and the data space technologies are made and are being made with the motivation to share data between parties. But still, once you focus on the current state on the data space technology, the situation is quite fragmented. So it's quite visible to these first years of the internet, when we had the multiple isolated networks like ARPANET or BitNet with their own communication protocols, but the connection in between was not there yet. But if you think about what really happened after that, so like introduction of TCP/IP protocol, that allowed these different networks, these fragments, to communicate with each other. then we had some kind of closer to what we know today as the internet. And Dataspace Protocol has this kind of role in the domain of the dataspace technologies, but it's also not only that one, because we know that the control plane and data plane separation was not explicitly mentioned in the TCP/IP protocol's first versions, but it came with this work that's happened after software-defined networking. And so what is good about Dataspace Protocol is that all these features, all these good features are coming in a package. But there is also one thing missing, which is the rise of the solutions to make the technology accessible and usable by the end users, by the organizations, to make it easy. So this will definitely result in widespread adoption of Dataspace Protocol and also the Dataspace technology. So once we have usable and highly usable solutions available for data spaces, then we will have this technology being adopted and get into a much better place. So basically, what we need is that we need more contributors in this development plane, I would say, for data spaces. So we need more and more usable solutions, more and more implementations, and also more contributors for the data space protocol. So as I mentioned right in the beginning, so we are in the version 0.8, and a stable version for Dataspace Protocol, so version 1, is expected to be out in the new year, or towards the new year, so in the upcoming weeks and months. So please check it out, and please also check the GitHub repository and contribute to it. So more contributors will just make our Dataspace Protocol a better one. So please, you are warmly invited to join us on GitHub and also apply Dataspace Protocol in your projects. So thank you very much. Then in the next session, we will be continuing with Marcus Spiekermann about Eclipse Dataspace Components and Dataspace Protocol. Thank you.